Here we have a couple of isosceles triangles. BAD is an isosceles triangle, BA equals to AD. And also triangle ACB is an isosceles triangle, BC equals to AC. The other thing we have here is that angle BAE is 60 degrees, and AC splits the angle DAE in half. So angle DAC equals to angle CAE. And we ask to find this red angle, ADC. AC is a bisector of the angle DAE. And when I look at bisectors, I'm thinking about symmetry. So what I would like to do is to take everything above AC and reflect it below AC. And if we do that, this is what we're going to see. And now let's clean up our image. What are we going to do? We're going to call D prime as an image of point D and B prime as an image of point B after the reflection. And now let's look at the angle DAB prime. Notice this angle is the reflection of the angle D prime AB. So it should be congruent to that angle, but angle D prime AB is 60 degrees, so DAB prime is also 60 degrees. And now notice we have this angle of 60 degrees that lays between two congruent sides, AD and AB prime. If I connect D and B prime, I'm going to get an isosceles triangle. But that's an isosceles triangle that has an angle of 60 degrees in it. So this is actually equilateral triangle. So AD and B prime D are congruent to each other. But now notice the point D as a vertex of an isosceles triangle, ADB prime, and point C as a vertex of an isosceles triangle, ACB prime. C is laying at the same distance from point A and point B prime. Point D lays the same distance from point A and point B prime. And we know that the points that lay the same distance from 2 points are laying on the line, and that line is at 90 degrees to the line AB prime. And in fact, point F is also in the middle of the segment AB prime. And now we got ourselves triangle ADF, which is a right triangle. One angle here is 60 degrees, therefore the other angle has to be 30 degrees.